Good afternoon, everyone. Welcome back to machine learning with supervised learning. I've been a SR programmer. As usual, I'll ask you to like this video, subscribe to the channel, leave a comment, share the video as well. Today we're going to be looking at model calibration and interpreting probabilities in classification. So we're going to understand what model calibration means and why it matters. Then we'll look at a demo of a Python code that will best demonstrate what we're looking at. So let's define some key concepts. First of all, what is model calibration? This is how well-predicted probabilities of a model reflect true likelihoods. A well-calibrated model's confidence scores match actual outcome frequencies. And we have what we call predicted probability. So instead of just predicting classes, models often output the probability of each class. Excuse me. Say, for example, it would output something like 70% chance of class A. Let's say the classes are alphabetical. Then we have a calibration curve, a reliability diagram, which is a plot comparing predicted probabilities against observed frequencies. And I think we looked at this in week 1 of machine learning. Then we have what we call the Brier score. A Brier score is a metric measuring the mean squared difference between predicted probabilities and actual outcomes. If the score is low, that means it's better calibration. If it's high, that means it's bad calibration. And we have what we call plot scaling and isotonic regression. Meanwhile, I hope I'm audible enough because of the rain here. So as I say, we have what we call plot scaling and isotonic regression. These are popular methods used to recalibrate model probabilities. So those are the key concepts to learn or know before we dive into the demo. So I have my file I've created here called model cal. Yep, so this is it. Let's break it down from I guess from the inputs, because there's some inputs that we haven't worked with before. We've worked with the decision tree classifier. Now, so these are the last two that we haven't worked with before. The calibration inputs, calibration curve, calibrated classifier, CV, the Breyer score loss. So that imports the calibration utilities and Breyer score loss metrics from the science kit. Learn Python library, and then line 10. Of course, by now I think you should be knowing how we load that iris data. So we've loaded the iris data, line 10 and 11, and then we load the iris features X and labels Y. Then line 14, that converts a multi-class problem to binary classification. And then so it's basically, in simple terms, it's class 0 being iris setosa plus the others. Then we split the data into 70% for training, that's line 17, and 30% for test sets. Then line 20, 21, that initializes and trains and calibrated decision tree on training data. And then line 24 predicts test data probabilities of positive class, which is class 0, by selecting probability in column 1. This. And then line 27, that line there computes the calibration curve, which is the reliability diagram for the uncalibrated model with 10 bins. Line 27. And line 30 to 32, that applies isotonic regression calibration to the trained classifier, and then fits the calibration model, and then predicts the calibrated probabilities on test data. So here is where we fit the calibrated model, and then it predicts the calibrated probabilities on test data. In line 35, computes the calibration curve for the calibrated probabilities. And then of course 38, 39 calculates and then prints the Bragg scores from before and after calibration. And remember, the lower the scores, the better. And then of course here we're plotting the calibration curve, so it plots the calibration curves comparing uncalibrated and calibrated model. Perfectly calibrated model's curve lies on the diagonal. So in summary, what this script does is it demonstrates how to evaluate and improve the probability calibration of a classification model. It then compares the uncalibrated decision trees' predicted probabilities with those recalibrated via the isotonic regression using reliability diagrams and Bragg scores. Well-calibrated probabilities mean predicted confidences better reflect actual outcomes. It's critical for making trustable AI decisions, especially in sensitive applications. So when I run this, we'll then look at the output and explain what we're seeing. I'll try and explain. I'm sure that it was raining, but I'm going back. Calibration. Okay, so it seems I was using an outdated method. That explains the error I got. So I had to change the keyword from calibration to method. Yeah. So maybe just to break down what we're seeing in the terminal, and let me first minimize the graph or the curve. So yeah, we expected the Bragg scores, which is the quantitative measure of calibration, to be low, and what we're seeing here is 0 on both the calibrated and uncalibrated side. And now for the curve, this is basically the visual confirmation. Calibrated curve should be it should be closer to the diagonal line, indicating better alignment between predicted probabilities and true frequencies. And as you can see, it's a straight diagonal line, which is good, which is what we're expecting. Yeah, so that's it for model calibration. And so yeah, that's it for model calibration and interpreting probabilities in classification, data classification basically. So that's it. Thank you for tuning in. Don't forget to like the video, comment, subscribe, and share. Have a blessed day. Yes.